Okay, we're going to solve the generic equation ax squared plus bx plus c by using the completing the squared technique. First step in completing the squared technique is to get the x squared and x by themselves on one side. I'm going to do that by removing the c with subtraction. So I have subtracted c from both sides. The next step in completing the square of this object is to get rid of the a that's in front of the x squared. To remove that a, it's connected by multiplication. I will break that multiplication with division, which means I will divide each and every object by a, leaving me with x squared plus b over ax equals negative c over a. I am now going to generate a perfect square trinomial by identifying n and n squared. I will start this off by allowing negative 2n to equal the number in front of x. I will now solve for n by dividing both sides by negative 2. I'm going to move the negative to the top because a negative in a fraction should never be in the denominator. It can be in the numerator or out front, but never in the denominator. So now I have identified n. The next step is to identify n squared. I will identify n squared by squaring both sides. Negative b times negative b is b squared. 2 times 2 is 4. And a times a is a squared. So I have identified n, and I have identified n squared. To produce the perfect square trinomial, I have to add n squared to both sides. So I am going to add b squared over 4a squared to both sides. Now, when I add it to the right side, you might want to notice that the c is negative. So I'm going to have a positive object and I'm going to have a negative object. I'm going to write the positive object in front of the negative object. Less signs that way. I see two fractions. I'd like to add my two fractions together. To add two fractions together, I need a common denominator. The lowest common denominator for those two objects would be 4a squared. The second fraction then is missing a factor of 4, and it's missing a factor of a. Over here then I have b squared over 4a squared minus 4ac over 4a squared. On the left-hand side, I have a perfect square trinomial. I can put it in the factored format. The factored format is x minus n. N is negative b over 2a. For right now, I'm going to leave the left-hand side alone. I'm going to simplify the right-hand side. one denominator, which means the numerator has all the work in it. I'm now going to solve for x by removing everything away from the x. The first thing I'm going to remove is that exponent outside the parentheses by taking the square root of both sides. So when I take the square root of both sides, I end up with a plus and a minus square root of b squared minus 4ac over 4a squared. I'm going to move this up. You can continue to see my work. Next step. I'm going to simplify that radical. The radical has a denominator that is a perfect square, which means I can take the square root of it, leaving me x plus b over 2a equals plus or minus the square root of b squared minus 4ac over 2a. Next step. Let me just pull this piece of paper down here for a little bit. Next step, I'm going to move this over to this side by subtracting it, even though it's a negative, so I don't get confused what's in front of the radical and what's behind the radical or in the radical. I'm going to make it up front, giving me x equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. Notice both of these fractions have the same denominator, which means all the addition and subtraction can occur in the numerator. So I'm going to slide this up and this down and continue my process. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. And that is where the quadratic formula comes from.